Hello everyone, my name is Hongzhi and my project is analysis and optimization for New York City public transportation alternatives. Uh, the agenda for today is that I want to first go over the overall code and tech stack as well as the dataset used in this project with a focus on the progress made after the midpoint presentation. Then I'll run a demo of a web-based application with some conclusion and thoughts we get from analysis, as well as some of the challenges and the improvement that can be done. So the overall goal first we have is that we want to get a high level understanding of the trend and usage pattern of the three key components for the public transportation alternatives, being the taxi service, the for-hire vehicle like Uber, Lyft, as well as the city bike. And then we want to drill down to get some stats on the specifics of if you were to take a trip from one neighborhood to another at a particular time of the day, how much money and time would it cost to use each of these tools. And then given those data, we want to build a very easy to use and intuitive tool for the end user to visualize these. And for that, we think interactive map is a good fit. A demo on that will follow. Most of the tools we used in this project is run on Google Cloud Platform. Specifically for all the data joining, filtering, aggregation, we use PySpark from Dataproc. All the data is hosted on cloud storage from raw data to intermediary to the final results. In the second part of the project, we use BigQuery intensively with a heavy reliance on GIS feature to do geometric computation and analysis. The web app is built on Django and the visualization is done using D3 and Vega. Vega is the JS library that's built on top of D3, so it gives you a high level abstraction and with some extra flexibility. The data set we used is from the past 3 years of the aggregate from TLC for taxi as well as high volume for hire vehicles. For the city bike, they don't provide any aggregate, so we have to get the trip data and then do the aggregation manually. We also get the TLC taxi data for the trips, and because we need to build a map-based app, so we also get the NYC borough map file in a GeoJSON format from NYC Open Data, as well as the taxi zone file from TLC. So run a demo here. So this is the map, and on the top you can see you can choose a time window. Because our focus is for commuting, so we didn't like evenly split the time from every 2-3 hours, but rather we split to the morning rush hour, and the middle of the day, afternoon rush hour, and then after that. So you can see the highlight is in red. It's a starting point, so you can click on any of the zone that changes the starting point. And then you hover the mouse to another zone, which is your destination zone. So whenever you hover the mouse, the pop-up is going to change. So for example, here from the highlight red zone is the Midtown East, and then our destination is West Village at a 4 p.m. to 7 p.m. time slot. If you were to take a trip using bike versus vehicle, it's going to cost you 22 minutes versus 27 minutes and $70. So this gives some very intuitive data from one point to another at a particular time. To get some interesting thoughts, I grab a bunch of screenshots and put them side to side to compare the data. Now come back to here. So the first one is the crosstown rush hour impact I want to show you. The same trip from Midtown East to Clinton East from different time. One is from the rush hour 4 p.m. One is off rush hour 10 p.m. So the bike travel time doesn't change much. It's 10 minutes versus 9. But the vehicle travel time, if you take a taxi or Uber, it's 19 minutes at rush hour versus 30 minutes off rush hour. So it's almost 1/3 less if you take use a vehicle at non-rush hour. Then the second one, I want to show you the distance impact on travel time. So on the left side, we take from Midtown East to Midtown Center at the same time, 10 p.m. The bike takes only 5 minutes, vehicle takes 8 minutes. And the second one is a much longer distance from Midtown East to Tribeca. Bike takes longer, which is 28 minutes versus for a car, it's only 21 minutes. So shorter distance, clearly the bike has an edge here. But if you were to cross the bridge, that changes the game. in this one, it show you that from Dumbo to Chinatown, there are two adjacent zones, but the bike takes 16 minutes versus the vehicle only takes 6 minutes. Then some of the comparison for the fare incurred if you were to take a taxi during rush hour versus not. So the same trip from Midtown East to Soho at 4 p.m. it's $19. At 10 p.m. it's $15. It's a significant difference here. So with this map, for the end user, you can get a good gauge of how much money and time would I take if I to take a trip from here to there, and then you can pick which one is a better fit here. Some of the conclusions we get is that different tools plays a different role here. And in the past couple years, taxi being the incumbent is the usage is decreasing, and the for-hire vehicle and the city bikes gaining more and more shares from taxi service. And the city bike has an edge here for it's both faster and more budget friendly for shorter trips and rush hour trips, versus the taxi and for-hire vehicle is a better choice for most of the long distance trip and cross-bridge trips. And then I'll talk about some of the challenges. The biggest challenge is that because data is provided from different organizations, so there's no cohesive format. For example, the trip data from TLC goes from zone by zone. If we were to draw a zone on the map, it's a polygon, so it's a shape. But the city bike trips were taken from one station to another in a format of latitude and longitude. If you to draw the station on the map, it's a point, and you can't really compare the polygon to a point. So a solution we use here is that you use the BigQuery GIS feature to do the joining. You can figure out from which specific zone of a particular station belongs to, and then you can compare from zone to zone. Another one I think that can be improved is that we didn't have much data to showcase the congestion and the rush hour surcharge, which could be a game-changing factor here. Because the congestion fee only takes place in the later this year, so we don't have this data just yet. But if we come back later, we get a better idea. That could give city bike even better edge if we were to take a trip across the congestion area. I think that pretty much concludes the project, and thank you everyone for your time again.